Hello and welcome to our 5th day of studying polars. Today we're going to learn more about conic sections. Now, to start this off, we want to make sure our window, or first off, that we're in polar coordinates. Today we're going to be in degrees, and let's move our window to these values: 0, 6.28, 0.13, and then x's go from -2 to 2, and y's are from -2 to 2 also. The first thing we're going to graph is this equation. So in our y equals, which is now r equals, we type in 1 over 1 plus 2 cosine theta. If we take a look at the graph, this is a hyperbola. So this hyperbola, I can throw it on here, I guess. We want to show algebraically that this equation can be a hyperbola. Well, the first thing we do is we want to multiply both sides by this denominator. So I'll have r times 1 plus 2 cosine theta equals 1. Now I distribute my r over my parentheses, so I have r plus 2r cosine theta is equal to 1. Now we have to think about rules that we had before. We know r squared is equal to x squared plus y squared. So what is r equal to? Well, we can square root both sides, and r is going to be the square root of x squared plus y squared. We also learned that r cosine theta is equal to x. So we can substitute these values in here. R is now the square root of x squared plus y squared, and r plus cosine theta is now x. So now we have to solve this a little bit further. I can subtract 2x on both sides, so the square root of x squared plus y squared is equal to 1 minus 2x. Now I will square both sides, so x squared plus y squared is equal to 1 minus 2x squared. Now 1 minus 2x squared we can either FOIL, use your sneaky squares, whatever method you want, and your answer is going to be 1 minus 4x plus 4x squared. So now if I subtract 4x on both sides, this would be negative 3x squared plus y squared equals 1 minus 4x. Now we could keep going with this problem further and further and completing the square and such. But from here, hopefully everybody can tell that it's a hyperbola because we have one of the x squareds is positive, one of the variable squareds is positive, and the other one is negative. All right, let's take a look at this. R equals 1 over 2 minus 1 cosines of theta. So 1 over 2 minus 1 cosine theta. Now that looks like an ellipse. So let's try to show algebraically why this is an ellipse. Now I think if you feel like you can do this, you can pause it and try to do it yourself. It's fairly similar to the last problem. You multiply each side by 2 minus 1 cosine theta. Multiply over the parentheses. Now this is just going to be x, and this is going to be the square root of x squared plus y squared. If you don't understand this, you can go back to the previous slide and see the equations that I used. All right, now we add x. So 2 square root of x squared plus y squared is equal to 1 plus x. Now we can divide by 2. X squared plus y squared equals 1 plus x over 2. Now if we square both sides, we'll have x squared plus y squared equals this whole thing squared. So 2 squared is 4. This numerator squared would be 1 plus 2x plus x squared. So we could simplify this to being 1/4 plus 1/2 x plus 1/4 x squared. So now if we subtract x squared from both sides, this would be 3/4 x squared plus y squared equals 1/4 plus 1/2 x. And again, we can continue with this and figure out exactly what it would look like. However, from here, if I put my squared in, since both these coefficients are positive, we know that this is going to be an ellipse. All right. Now, what kind of shape is this? Let's plot it first. Nine divided by 4 minus 4 sine theta. Now it looks like it is a parabola. Let's zoom out to see if there's not another side of that parabola. Just looks like a parabola to me, so we can zoom back in. Now, let's see if we can show algebraically why this is a parabola. So we just have an r here, and if we multiply both sides, we'll have r 4 minus 4 sine theta is equal to 9. When I distribute it, I have r times 4 minus 4 r sine of theta is equal to 9. So now what we'll do is convert it again. So r is the square root of x squared plus y squared. And this will be, now we learned before that y is equal to r sine of theta. So this is the equation we'll use here. And it would be minus 4y is equal to 9. So now we'll add 4y and divide by 4. We can do this one step at a time. No reason to hurry through this. X squared plus y squared equals 9 plus 4y. Divide by 4. Now square both sides. So x squared plus y squared is equal to, if we multiply this numerator out, it's going to be 81 plus 36 plus 36, which is 72y. And then that's going to be plus 16y squared all over 4. So we can divide those out. 81 divided by 4 is 20.25, 20 and a fourth. 72 divided by 4 is going to be 18. And then this is 16y squared. Now, I just noticed a mistake that I made. And my mistake, hopefully you guys caught this. This 4 had to be squared to get 16. And so that changes these values down here. I apologize for that. You're probably wondering what I was doing. All right, now if we take 81 over 16, That's 5.0625. 72 divided by 16, that would be 4.5y. And 16 divided by 16 will be y squared. I noticed that something was off because I knew it was a parabola, but we can't have both an x squared and y squared. So now what we do, we subtract out my y squareds. So I have x squared equals 5.0625 plus 4.5y. Now again, we could solve this for perfect squares and find exactly what this looks like. But from this is good enough because we have 1x squared and one variable that's not squared. So this is enough to know that it's a parabola. All right. Now what I would like you to do is take some time with this graph, with these two equations. These are basic equations, and figure out what A and B do. What happens when A is bigger than B? What happens when A is less than B? And what happens when A is equal to B? Do that with cosine and do it with sine. Try as many numbers as you can before you see a pattern. In this graph, 2 is bigger than 1, and we got a hyperbola. In this graph, we have this value is bigger than, this 2 is bigger than that one, and we got a ellipse. When they were equal, we had a parabola. Now, does it make a difference using sine or cosine? So if I took this graph, my last one, and if I just change this value to cosine, how does that affect the graph? Well, that affected that one quite a bit. Instead of being on the x-axis, now, or instead of opening up, now it's opening to the right. Try and see what happens when you change it for the hyperbola and for the ellipse. All right, hopefully you saw the pattern. This is part of your homework. You should have a worksheet to go along with this.